Okay, I hope you enjoy miniature break. I'm going to invite the first speaker of the next session, Victor, to start the presentation.
Can you see it?
Yeah, great, go ahead.
Okay. So, well, my name
Oh, Victor, I'm afraid you've frozen, so perhaps turn your camera off, see if that helps with bandwidth.
Okay. I don't have the. Oops.
Go ahead, share your screen again. Let's try again.
Nope.
Looks good. Go ahead.
Okay. So, as I said, the OWLAB Signal Processing Laboratory in the University of the Basque Country, and our identification in this challenge was letter E. Of high quality audio by a single Spanish female speaker, along with its corresponding transcriptions. Our team submitted a proposal just Spanish words, and the spoke task, which is pretty similar, but text could contain a few number of English words. The computation restriction in our available hardware, we decided to trim audios longer than to remove audios longer than 15 seconds in order to prevent out-of-memory errors. And 0.5 of the total corpus. Audios were decimated to 22.05 of that were obtained. We did this by using a linguistic frontend developed by our lab. So this frontend is publicly available and it can be found in the link. Once the phonemes were obtained, we also extracted the alignment between them and the audio, making use of Montreal First Aligned for 3 different purposes. First of all, we used this information to trim the tail silence of the audios to a maximum of 0.3 seconds. Help with the future training of the acoustic model. Also, inspecting the obtained alignments, we noticed that some of the pauses in text didn't correspond to actual pauses in the audio. Position them according to the alignment information. Finally, we obtained the alignment graphs because we would later use. So this is an overview of the architecture of the system. Here we can see that basically first we have a Spanish linguistic frontend, the same one we mentioned before. With an extended addition, which would be adding a pre-alignment guided attention. And finally, we would have a Waveler neural vocoder. Frontend. Along with the stress level of each phone. So here we have an example in this sentence, which would be, hizo ayer 50 años que la ley entró en vigor. The output of our frontend with stress level of the phones, and also here we have the number which has been expanded. the acoustic model. No, it is in this part of the system where we implemented our proposal for the spoke task. James to articulation of an idea. So after passing it through the front end, we would
Además, pasar un rato en compañía de James Stewart y
detection tool based on simply a lexicon lookup using the CMU dictionary as reference, and a conversion from therefore the system would identify the English words and would adapt the pronunciation of those words to a more suitable one. Here we would have the words detected as English and the final result. So it could sound like this.
además, pasar un rato en compañía de James Stewart y Grace Kelly siempre es buena idea.
So model, we used the Takachon 2 base model. We trained it using the phonemes obtained in the previous step, and we also added an additional lost term proposed in the paper. It was a NVIDIA Titan RTX, and we used the following params: batch size of 64, learning rate of 0.00. For 230,000 steps. So the results, here we have the evaluation. We can see that our system has an average performance among all teams in terms of naturalness and similarity. Regarding intelligibility, our system doesn't have one of the lowest word error rates, but still there's no statistical significant differences to those performing best. And there's not much to comment in here, but we can see that our model achieved quite good overall performance in the 3 evaluated aspects. So we are very pleased with the results. So finally, here we have a summary of the system we submitted to the challenge. If the system with a Spanish linguistic frontend, Takachon 2 as acoustic model with pre-alignment guided attention, and the fine-tuned wave-low vocoder. Here are a couple of samples.
Aprender las lecciones del pasado y no volver a fallar a la ciudadanía.
Oh.
Sin importar cuán poderoso o avanzado pueda ser.
So to conclude, improvements, but there's still very large room for improvement, especially on the vocoder, where we think that the naturalness of the model could have benefited from data and or even for being trained on the GTMLs extracted from the acoustic model.
Victor, thank you very much. Unfortunately, your audio was very intermittent. Your connection seems to be choppy.
I'm sorry.
So, not your fault. what I suggest, we won't take questions this way. Just if you have a question for Victor, please use the chat where he'll respond to you there. And so we'll just move on to the next presentation. If you want to stop screen sharing, please, Victor.
Oh, yeah.
And the next presentation is from National University of Singapore. Xu Hao.
Yes, hello, I'm here.
Please go ahead.
Okay. So can I open my video or okay?
Great.
So can you hear my
Screen.
sound?
Go ahead. Yep.
Okay, so I share my screen. Hello everyone, I'm Xianhao Zhou. I'm from National University of Singapore. Today I will present our paper SOTD NOS system for Blizzard Challenge 2021. And my presentation will follow these outlines. I will talk about the task overview first, then I will introduce our system architecture. This year, Blizzard Challenge 2021 has two tasks. The first one is to synthesize the Spanish voice using the 5 hours European Spanish data. And the second task is to synthesize the voice from the Spanish text containing a small amount of English words using the same data as the task one. And we participate the two tasks. Then I will talk about our system architecture. Our system is N2N TTI system plus the neural vocoder. Our N2N TTI system is the modified Takotron2 system. We use the Takotron2. We use the modified Takotron2 system to convert the input to the MEL spectrogram. So we use the MEL spectrogram as our acoustic features. And for the neural vocoder, we use the MEL GAN vocoder to convert the MEL spectrogram to the waveform. Then I will talk about our system architecture details. So for our modified Takotron2 system, because the English alphabet can share with the Spanish alphabet, so we just use the character sequence as the TTS input. Additionally, we find that different tongue symbols can represent different information, can represent additional different information. Here is two sentences. We can find that the different symbol represent the different tongue symbol represent the question and the exclamation respectively. So we utilize the tongue information in the input representation. Specifically, we concatenate the character embedding with the tongue embedding to form the input representation of our TTI system. This character embedding is obtained from one lookup table, and this tongue embedding is obtained from another different lookup table. Then I will talk about our TTI system. So our TTI system is based on encoder and attention-based decoder. We use the CBHJ as our encoder part. So the input representation is passed to a prenet followed by the CBHJ encoder to extract the latent text information. And for the attention part and the decoder part is the same as the Takotron2 system. And the attention is location sensitive attention, and the decoder part is the autoregressive recurrent neural network. And finally, we use the MEL GAN to generate the waveform from the predict MEL spectrogram. For the MEL GAN vocoder, we use the adversarial loss and the multi-resolution ST-FT loss. The multi-resolution ST-FT loss can improve the stability of the training procedure. So we use it in our MEL GAN vocoder training part. So here is my presentation. Thank you for listening.
Thank you. We do have time for some questions. I was curious about the choice of letters as the common representation between two languages. I just wonder if you could sort of motivate that a bit more, because the letter to sound mapping in Spanish and in English are very different.
Yes, here we just use the common letter to represent the English word and the Spanish word.
But I was wondering what was the motivation for that, other than it's easy.
Yeah, yes, it's straightforward.
Do you think it worked, given the kind of results on the mixed language task?
You mean another language task, or?
Well, I mean, do you think this method works? I think using letters for one language is plausible, certainly for Spanish. But for English, it's less obvious. And for two languages where the spellings are really quite different, I'm struggling to see the motivation for doing that.
Motivation is just that it is straightforward to use the character to.
Any other questions? Okay, that's good. Thank you very much. I'll let you stop the screen share and we'll move on to the next
Thank you very much.
presentation.
Thanks for listening.
Thank you very much. From the
Let's
TAL
talk.
group, it's Xiaotong.
Okay, I will share my screen. Is that clear?
Great, go ahead.
Okay. I'm Guo Shaotong from TAL Education Group. And on behalf of our teams, I will introduce our system for Blizzard Challenge 2021. The task of Blizzard Challenge 2021 is build a TDI system of Spanish. And this is the first time we participated in this challenge. So we only submitted the result for half task. For half task, we built a Spanish TDI system based on reaching the word model, GST acoustic model, and Hafgan vocoder. The provided data by committee contains about 9.7 hours, and we processed this audio and used about 4 hours for system training. The total education, the total duration of external data is about 95 hours, including a subset from ML Labs and a subset from PHL3. The subset of ML Labs and process the provided data used for acoustic model training, and the total data for vocoder training. The processing of provided data described as below. First, we removed all audios that contain English words, and we manually put the silence at the start and the end of the audio, and replaced by a fixed length silence. Finally, we downsample and denoise the remaining files and extract the new spectrogram for training. Our proposed system consists 3 parts. The first part is a rule-based frontend, which will convert the Spanish words into a Spanish phoneme sequence. And the second part is a acoustic model based on GST, in which we use pre-trained word model to extract the linguistic feature, as shown in Figure 1. The red part every Spanish word will tokenize them into few tokens, and we will choose the middle tokens to represent the whole word, and and upsample these subwords in value according to the length of phonemes, and concatenate them as the encoder inputs. In the vocoder, we use half-gun as vocoder. In the training stage, we train the acoustic model and encoder separately, and the data provided by committee were used for both two models. For results, as shown in figure 2, our system, the letter B, the mean opinion score is in a middle level in all evaluated system. However, the similar score is lags behind the most of systems. The figure 4 and figure 5 shows the WER results. For SUS test, our system together with the system B and F achieve the lowest level of WER results. And for showered test, our system still performs good. So for conclusion, in our system, we mainly use a word-level linguistic feature from the pre-trained model to improve the prosody and intelligibility, and a half-gun as the vocoder to generate high-level speech. In the future, we will continue to investigate how the linguistic feature influence the result of TDS system, how to make a better using of the linguistic information. Okay, thanks. Does anyone have any questions?
Thank you. Yeah, we do have time for questions. These rapid fire presentations getting us back on schedule. That's fine. While we wait for others, I did have a question about the denoising. You mentioned denoising the data. I wonder why you thought that was necessary. I didn't see other teams doing that because this was studio data. Or are you talking about denoising the other data set?
I can explain this question. I analyzed the data provided by committee, and this have a low level noise, but it's not very high. I'm scared that the low level noise will influence the final result, so we use the denoise. In the months ago, I use a data set with noise, and it damages the final result. So I do the denoise to in case that get a better result.
And what was the method for denoising?
It's just a very simple internal tools.
But what's the method? What is it? Is it spectral subtraction or something more sophisticated?
Seems like signal processing based tools. It's provided by my partner, but I don't know the more details of the tools.
Okay, Zenwa has a question.
Okay, I want to ask about the implementation of the GST. So at the inference time, how do you predict the tokens? Do you use the reference utterance, or you just set the token weights manually? How do you do that at the inference stage?
I use the mirror spectrogram from the training data, just the random select one of them.
Okay, you mean you just random select utterance as the reference one? Okay. Do you make any comparisons? For example, you can choose one utterance, or you can use some mean or average token weights or something. Did you make any comparisons among different strategies?
For GST model, we didn't use it. We use we compare this method for the other methods, such as replace the GST by S3 models, speaker verification models.
Okay. So you use BERT to extract the linguistic features. So do you fine-tune the BERT, or the BERT is fixed?
No, we just use the pre-trained BERT
Okay.
model.
You didn't fine-tune the model.
Yeah, multilingual BERT.
Okay. Yeah, I see. Thank you.
Thank you.
Thanks, Emma. Any other questions? Great, thank you very much for the presentation. I'll let you stop screen sharing, and that brings us to the final presentation of the session and of the workshop. And as is traditional in Blizzard, we save the team that got the highest naturalness score on the hub task for last, and that this year was the team from Microsoft. So Yanqing, please go ahead.
Yeah, sure. Sorry, I don't have a video. So can you see my screen?
Yes, we can.
Yeah. Hello, Simon and Zhenhua. I'm from Microsoft Speech Group, and I will introduce our system today on behalf of our team. So this is my agenda today. I will first introduce the motivation and challenges related to the data set this year, and then introduce our solution and share some results. Okay. So as we know, although there is much progress in the latest research in TTS, but the quality of synthesized speech still has quality, especially perception issue and naturalness issue compared to the recorded speech. So some probably relied on the acoustic model because the one-to-many mapping problem, and also the acoustic model did not make full use of some acoustic feature besides the test information. So we think there is much room to improve, and also the current model has some problem, especially in the acoustic model. So for this year task, the data set is 48K, and so the problem for acoustic model is bigger than traditional data set like 16 or 26, 24, 24. Because the modeling sequence is actually longer, and the modeling requirement for acoustic model and vocoder is harder too. So in our proposed solution, we decided to use 16K spectrum for acoustic model, predicted from test-only data, and For vocoder, we input 16K spectrum and predict 48K samples. We think this will achieve quite a good balance between the voice quality and modeling efficiency. So there is overall there is the three main components in our models: the test encoder, variance adapter, and the male decoder. So the input to test encoder is the phone sequence, and also there is some word boundary. And the variance adapter will try to model the pitch and the duration, and some processed vector extracted from the male spectrum. And then the last part, the male decoder takes the test data and the pitch, duration, and the processed vector extracted from the spectrum to predict the final male spectrum. Traditionally, the modeling block for acoustic model, especially non-autoregressive model, is transformer or LSTM. In our solution, we introduced an improved conformer block. So from last year, conformer is achieving the best quality in speech recognition, and we think it will also the design hence besides the conformer will also benefit TTS. So basically, we there is some improvement from the original conformer. First, we switched the depth-wise convolution and attention order. In the original design, the subtension is before the depth-wise convolution. And also we replace the feed-forward layers. There are the two feed-forward layers in the original design, and we replace it with the convolutional feed-forward layers. And also we didn't use the switch activation function, and we replaced it with the ReLU layers. We found it's better in TTS. So this is the basic block for encoder and decoder. For the variance adapter, basically we introduced two kind of information: the explicit information and the implicit information. The explicit information includes the speaker ID, language ID, and the pitch value, duration. And the implicit information includes utterance process vector and phoneme level process vector. During training, we use the ground truth values, and during inference, we predict these values like pitch, duration, utterance level, and phoneme level process vector from the test information. So our data set includes the provided data from Blizzard and an internal data set about 80 hours data. So in Naturalness Test, we achieve a mean score which is higher than other systems, other TTS systems. And our score is not significantly different to the natural speech. So in the similarity test, we are also achieving a higher score than other systems. And the SUS, we also achieve the lowest WER as system B, and which is lower than other systems too. But in the last part, showered interpretive test, we are not performing very well. Yeah. So this is all. Thank you. Any question?
We've got a question immediately from Alejandro. Go ahead and unmute yourself.
Thank you, Simon. Thank you for the presentation. I was wondering if this HIFINet vocoder model is so the details are publicly available in some work, or this is an internal model, and also if you could give us a brief description of this vocoder model. Thank you.
Yeah, thank you. So the HIFINet vocoder is an internal model, and we have a public blog to introduce its structure and the quality. We didn't publish a paper related to it, and basically it's based on discriminator, and in our internal test for different language and different voice, it's performing pretty good. For TTS, we think the bottleneck is the acoustic model. So I don't think this is the most important part for this task in our system. Yeah.
Okay, thank you very much.
Just raise hands or use the chat. Could I follow on the sort of vocoder question? So you made two design choices here. One is the acoustic model generates spectrograms with an 8 kilohertz bandwidth. And then the vocoder goes all the way up to 48 rather than, for example, 24. I was wondering, did you try different options for these two choices? For example, the acoustic model could have done something less than 16, or the vocoder, you know, is there really a perceptual win of going to 48K because most people can't hear?
Yeah, actually we tried another combination, that is the acoustic model also produces the same spectrum as vocoder, the 48 spectrum, but the quality is almost the same as the current choice, but you know, the acoustic model is much slower. Yeah, we didn't see obvious quality gap between the two systems, but the current version is much faster. Yeah.
Okay, so really it's about efficiency in the acoustic model. So what about going below 16K?
Yeah, it's a good question, and but we didn't test it. Yeah.
Okay, thanks. Questions from other people? Turn.
Hello.
Hi.
I want to ask about the usage of the external data. So did you use the data just for training the acoustic model, or you also use that for vocoder? I mean, is the vocoder a speaker dependent one, or you train it with some other speakers data together?
Yeah, for this task, for acoustic model and vocoder, we use the same data set. There are two parts in the data set. The first part is actually the private data from Blazor, and the second is our internal data set about 80 hours. Yeah.
Okay, so have you compared your results with the training only with the provided data? I mean, no external data. How about the performance?
Actually, we didn't do it because in our recipe we just think the multi-speaker data is better. Yeah.
Okay. Okay. Thank you.
Thanks. And other questions? I can always think of questions.
Okay. Thank
Given
you.
that your system was the one that was more similar to the reference speaker than the other samples of the reference speaker, I wonder if you have any intuitions about what happened there.
You mean for the modeling part, right?
Yeah, I mean, it can't literally sound more like it. It must be to do with the samples that were in the particular test or something about your model. I wonder if you have what your thoughts are on that you exceeded the similarity of some other recordings of the same person.
Okay. First, I think our design is trying to resolve the current challenge described here. You know, for the not regressive TTS model, acoustic model. If you just input the test only data, it's just not enough. So we designed the more variance data besides test only data, that is pitch, duration, and some process vector global utterance globally, and the fine-grained phone level process vector. So we think this is the right design, because if you want to solve the one-to-many problem in TTS, so you just need more variance information. Second, I think we use a powerful basic block conformer. It's provided a powerful modeling ability, as we have seen in the speech recognition community, and in our practice is performing better than the transformer or transformer plus convolution solution. Yeah, we also noticed the ESPNet also published similar result recently. Yeah. So these 2 points I think is the key points for the final quality. Yeah.
Okay, thanks. We can find time for more questions if people have them. João, go ahead.
Yeah, so thanks for nice presentation and system. Yeah, so maybe I'm going a bit a question that not specifically to this task, but for example, since your system can produce very high quality on this type of data, read speech, do you think it will also be good? Have you tried as well with more expressive kind of data? If you can kind of model it as well, the expressivity with this type of system?
Yeah, that's a good question. And actually, we also trying to use the same model to model the multi-style and the emotional data set. Actually, for different emotion or style, the result is quite different, because the model here is just to resolve the naturalness issue in current modeling method, and for the expressive data set, some styles we have a very good result similar to this data set, but for some too expressive voices and styles, actually it still have gap compared to the recorded speech.
Thanks. We had a question in the Q&A from Christian, but if you'd like to ask it live, that might be better.
Yeah, so I was wondering about more information on the implicit information in the variance adapter and how it is extracted. Is that another like in other things like a GST, or is it an autoencoder? What is it?
Yeah, for the implicit information for the alternate level is a similar solution as GST, and for the phone level processing, it's just similar to the alternate level, but it's used the phone level. Yeah, so it's both extracted from the male spectrum during training. During inference, we predict these values from the test data. Yeah.
Yeah, how does that work to predict it from the test data, because you don't have the spectrum? So during inference.
Yeah, we use the hidden state information from the test encoder, and because it's phone name level, and we predict the phone level process vector in inference. Yeah.
Okay. Thank you.
Thank you.
Thanks, Christian. Keep the questions coming. Any mode you like, Q&A, chat, raise your hand. Could I follow up on that? So I think in a lot of architectures, we're now seeing, take spectrogram, embed it with reference encoder idea. Then the question is, what do you do at inference time? In some other system papers today, we saw, give a random spectrogram. Here you built a separate predictor, predict it from the text. When you predict it from the text, is there any kind of concept of how accurately you can predict it?
Yeah, we didn't measure that, but if your data set is not big enough, there will be a problem, because the test patterns and to acoustic patterns, you just need enough data for a better predictor. Yeah.
Another version of the question will be, if you predict it from the correct input text, of course your system performs really well.
Yeah.
What if you just kind of predicted from random other text? Would it be worse? I'm trying to get, are you actually making a prediction from text, or are we kind of doing some clever random sampling?
Actually, I think the target, the correct, or the real variance information from the alternate level or phone level process vector, it doesn't need to be too precise, because you have other models like pitch and duration and test information. So we don't know what kind of information we extracted from the phone level and the alternate level, but yeah, it's maybe not too precise, but the result is it seems to be okay. Yeah.
Yeah, thank you. That seems a good intuition. Yeah.
Thank you.
Well, last chance to other people who want to ask questions. That feels like a natural end. It's been a long time on Zoom. It's a shame to do it this way. Hopefully we'll be in person next year. Thank you everybody for attending. Thank you very much to all of the participants and the audience for asking questions today. I'll let you stop screen sharing now, and I'll just have a few concluding remarks. normally at the end of the Blizzard workshop, we ask for a discussion about this year's task and next year's task. People don't seem super interactive today, so I'm not going to do that on Zoom. What I'm going to do is I'm going to invite people to send comments either to the Blizzard discuss list, if you're happy to do that in a public forum, or privately to us, the organizers, which is the blizzard@festvox.org address, with any comments you have at all about this year's task, whether you took part or not, and things you might like to see in future tasks. We'd like to hear things like, would you like to use this data set or just this language another time, now that we've invested some effort in Spanish? Should we do Spanish again next year? We could ask iFlyTech if they're willing to let the data remain available. That's one option. We have historically tried to run for more than 1 year on a single data set. We have another option, which is to add a language or replace it with another language, which would be French. That will be a much larger corpus of audiobook data that's already prepared and available. So that's provisionally what we might do next year. Might do the Spanish, might do the French, we might do both. But if everybody hates all of those ideas and has something better, we'd also like to hear that. So again, I invite your comments to us in emails, either on the discussion list or to just the organizers if you prefer it to be in private. And please do that, as soon as you can, and then we can make a decision on what we're doing for next year fairly soon and go ahead with that. And the real thing that remains to me, I'll ask Zenoir to come back on video. And if your assistant is there, the anonymously named host would like to reveal themselves if they're willing. I'd really like to thank Zenoir, who really ran the challenge almost completely this year. I did almost nothing, except occasionally answer questions very slowly and send some people from Prolific to the listening test. Thanks, Zenoir, for a very smoothly and efficiently run challenge, and indeed for running the workshop and the Zoom and everything as well. You made my year much more enjoyable than other years of Blizzard. So thank you very much. And I'm sure
you're welcome.
Join me in saying thank you very much to you. Thank you. I've got a question which I will actually answer now because it's pertinent. We've been recording the session. We'll need a little bit of time to prepare that, to cut out all the noisy bits, to remove the famous slide that reveals all the team's identifiers. And then I believe that SynSig will help us publish that on the SynSig YouTube channel. Zenoir, do you want to just confirm how that will happen?
Yes, it will be posted on the YouTube channel named SynSig ISCA. I will paste the URL here. I think that is to
right. We'll add a link to that on the Blizzard workshop.
I just press a link in the chat box to everyone.
Thanks very much. I think this is probably the same place that SSW videos were published.
Yeah.
So it'll be in the same place as that. If any presenters do not want that, they will contact us, the organizers, to say so. But by default, we will take your permission as given by presenting here today. So email us immediately if you do not want your presentation to be made public in that way. That's your right. And that's all from me. If anyone else has anything that they feel I should have announced or clarified, now is your chance to tell me so. No, I think we got it right. We're finishing on time in the end. That's great. Thank you very much for attending. I very much missed seeing people. I'm doubly annoyed because I missed another Blizzard workshop recently through being ill. But next year, maybe next year, let's all be optimistic that we will meet next year. So that's all from me. Thank you again, Zenoir, and thank you to all of the presenters. Got one hand up there from someone. Go ahead and speak. Yeah.
Sorry, I didn't mention to click this. Yeah.
Okay. Okay, no problem. Right. So thank you, everybody. And see you next time.
See you.
Thank you.
Yeah.
Thanks.
Thank you to organizers.
Thank you.
Thank you.
Thank you all.
Bye.
See you some places. Bye bye.